Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. In this video we are going to solve problem 3.1 from chapter number 3, Reversible and Irreversible Processes. Definitely these are reversible and irreversible thermodynamic processes from the book Applied Thermodynamics by Eastop and McConkey. The statement of the problem is 1 kilogram of air enclosed in a rigid container is initially at 4.8 bar and 150 degrees centigrade. The container is heated until the temperature is 200 degrees centigrade. Calculate the pressure of the air finally and the heat supplied during the process. So first of all we will write the given information in this problem. So we have given mass, that is 1 kilogram, and it is a rigid container, meaning that the initial volume will be equal to the final volume, and the pressure P1 is 4.8 bar. Similarly, temperature T1 is 150 degrees centigrade. The container is heated until the temperature is 200 degrees centigrade, meaning that the final temperature is 200 degrees centigrade. We have to calculate two terms or quantities. First one is the pressure P2, and second we have to find the heat supplied during the process in which the temperature rises from 150 degrees centigrade to 200 degrees centigrade. Coming to the solution of this problem, as it is mentioned in the statement that this is a rigid container, it means that the initial volume is equal to the final volume. So using this criteria, writing the state equation for the two states, one is initial and second is final. So for state 1, the characteristic equation of state will be P1, V1 is equal to mR T1. If we keep V1 on this side, so it will become mR T1 over P1. Similarly, for state 2, it will become P2, V2 is equal to mR T2. So if we keep V2 on left hand side, it will be equal to mR T2 by P2. So now as the container is rigid, so V1 is equal to V2. So right hand side of expression A and expression B will be also equal. So we can write that mR T1 over P1 is equal to, this is basically V1 and this is V2, mR T2 over P2. The mass is constant, that is 1 kilogram, so it will be cancelled. Similarly, the value of R is same for air, and it is 287 joule per kilogram per Kelvin. So we can write this expression like this: T1 over P1 is equal to T2 over P2. So we are interested to find the value of P2. So for that, rearranging this expression, we can write that P2 is equal to, if we cross multiply these, so it will come over here and it will become P2 and P1 will go there, so P1 into T2 divided by T1. So if we put the values, P2 will be equal to, the value of P1 is 4.8 bar and the temperature T2 is 200 degrees centigrade, but we will convert it to Kelvin, so 273 will be added with this and we will have 473 Kelvin. Similarly, T1 is in Kelvin 150 plus 273, so the value of T1 is equal to 3423 Kelvin. So the value of T2 is calculated, that is 473 Kelvin, and T1 is 423 Kelvin. So simplifying this, we will get the value of P2 and it comes out 5.37 bar. So now to find the value of Q, second we have to find the Q, heat supplied during the process. So it is constant volume process, so for that we have the expression Q is equal to mCV T2 minus T1. So we know about all these values, so putting the values directly, M is 1, the value of CV for air is 0.718 kilojoule per kilogram per Kelvin, so it will be 0.718 into the value of T2 is 473 and the value of T1 is 423. So simplifying this, the value of Q comes out 35.9 kilojoule per kilogram. So this is the value of heat added during the process, and it is the solution of problem 3.1. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.